this. If you see the last two things, I wantedly sent to the recording because, okay, once you access the recording, use it on your laptop. There'll be an option called as download something, or download or something will be there. There'll be an option. Fine. Keep that and name it. For example, after some point of time, it will automatically get cleared from my cloud. Okay. You won't be able to access to that, even though you guys have the link. I'm not even talking about that. Even though you guys don't have the link, even though you guys have the link, you won't be able to access to that. 120% out of those two things, one will for sure come as a 5 marker in your exams. For sure. Okay. Now, apart from that, in this chapter called as work per energy, what and all is important. I also told in the recording that I'll be sending you guys a PDF. What did I send? Okay. When I was trying to teach you that in the recording, I in a flow told you that I'll be sending, but once I saw the PDF, I realized that apart from those two concepts, there is one more important concept. And when you scroll through the PDF, the first difficult thing that you guys will come across is this concept, what I will be doing in today's class. Because of this concept is why I didn't send you the recording. Why I didn't send you the PDF. Once I'm done with this concept today, I'll send you the PDF. Now, in the total chapter, 3 important things. 1 3 marker, 1 5 marker will come. That 1 5 marker will come from one of those 2 recordings, 100% sure. That 1 3 marker will come from today's class right now. And apart from this, there'll be 1 markers and 2 markers. 1 markers and 2 markers, whatever you guys have learned in 10th standard, that is more than enough. That is one of the main advantages of you guys learning ICSE. Fine. The definition of work, unit of work, definition of power, unit of power, all these easier concepts will be asked as 1 or 2 marker. Not to be a problem at all. But all these things has to be kept in mind. You should not ignore it. In the PDF, all these things will be there. Make sure you guys go through it once. Don't ignore it. That's all. Fine. So today, we'll start off with the 3 marker what I told you. It is called as, okay, before telling, this specific concept is a theorem. Okay. How to learn it, how not to learn it. Before talking about this, I'll talk about that 1 marker, 2 markers for the next 5 to 6 minutes. They're asking about definition of work. W is equal to F into S. To be more precise, 1 minute. Learn it as F dot S. Okay, because the moment you put that cross symbol, it comes across as cross. Comes across as cross product as well as dot product. You should not be learning it that way. Always learn it in terms of the cross product itself. Because dot product, the other day when I taught you, or the cross product, I gave you a hint. Cross product meaning sin theta, dot product meaning cos theta. So here, once you expand this, everything is a vector here. So it becomes W is equal to F S cos theta. This is the actual definition of work. Now understand? This is the first thing. Second thing is when is 0 work done? I hope you guys remember the same 10th standard example. You place a heavy load on your head, okay, and you stand in one place. That heavy load is trying to apply some sort of force on your body, but you are not moving, which means since displacement was equal to 0, work also becomes equal to 0. This specific thing can be asked as a 1 marker or a 2 marker. What do I mean by 1 marker is MCQ. Fine. Now, what is the SI unit of work? Joule. Same concept, 10th standard concept. Nothing else is there. Dyne is there, erg is there, all those things you guys go through this concept. 0 work is there. Fine. Variable force, all these things ignore, not at all required. Numericals do not practice from the illustrations. I'll tell you what to practice from for now. Then energy. Energy meaning everybody knows there's nothing new here. All are 10th standard concepts. I'll read the definition from the PDF itself. It says the capacity to do work is called as energy. Everybody knows this. Capacity to do work is energy. Can we ignore the word capacity? 100% no. So write this. Again, 10th standard. What else is there? What quantity, scalar quantity, that, this, and all those things. Now, types of energy, there are many. What is required for us in this chapter? Kinetic energy as well as potential energy. K is equal to half mv square. Potential energy is equal to mgh. Potential energy always depends on the position of the object. Always. Kinetic energy obviously depends on half mv square. What? Mass as well as velocity of the object. Now, till now, the actual reason as to why I started with this 1 marker before doing the 3 marker is I could have done it directly. It's just that what the first concept what we learned was work. The second concept what we learned was energy. There is one theorem which combines both these smaller concepts and makes it a much more important concept. Okay, that theorem is what comes for 3 marks. That's the whole concept. Now K is equal to this. All those things you guys know. And one more thing, you come across mechanical energy also. You will know this. Let me revise. Mechanical energy is nothing but the sum of both PE and KE. Okay, this is how it works. Now, this is the regular stuff. Whatever I'm writing on the board right now is a 3 marker. It goes like this: work, energy, theorem. Okay, work, energy, theorem, 100% 3 marker. This I'm talking not only in terms of a board exam perspective, but also in terms of a college exam perspective. Remember this. As the name says, this is a concept which relates two things. One is work, one more is energy. Fine. Now, let's try to define what all is being given there. And how do we start off? Very simple. I want you guys to remember one thing. When we learned about this concept called as equations of motion, we came across 3 equations. One is V is equal to U plus AT. The second one is, okay, not the second one. Second one not important. Second one is S is equal to UT plus half AT square, not important. The third one is V square minus U square is equal to AS. What we require for deriving or understanding this concept is always the third equation. So start off a concept by writing V square minus U square is equal to 2AS. There is a reason as to why I'm starting to write from the left extreme, because the right extreme I'll use it to try to understand, to try to derive some few more things. Now, what are the few more things? This is my step number 1. Always my step number 1. Now, on the right hand side, what I'm going to do here is I will start trying to think what are all formulas of force I know. Okay, this is the equation of motion. Left hand side done. On the right hand side, I'm trying to think what are all formulas of force which I know. I know one simple one which is F is equal to MA. Okay, F is equal to MA. Now, at this point of time, I try to compare both of them. Look at how I'm going to compare. See what letter is being repeated in both the equations. Fine. I can see in this thing, I can see A. There also I can see A, which means the letter A or the concept called as acceleration has been repeated in both the concepts. So what I'm going to do, in this case, acceleration is going to be my hero. I'm going to write F is equal to MA in terms of acceleration. If you ask me why, the answer is here. Because I have a A here also and there also. So I'll keep the A there itself. It becomes force by mass. I mark this, I remember this. Okay, I mark this as well as remember this. Now if you see, ignore the right hand side. The reason I am so confident and trying to tell you, ignore the right hand side is because in the next step, I know what to do, what can be done. Instead of writing A, I can write F by M. So I at least have some clarity. This might be right, this might be wrong, I don't care. But at least have some kind of clarity. Left hand side, I have no clarity. So whenever you guys have no clarity, always go back to the question. In this, the question says work energy theorem. Fine. Work, W is equal to F into S. Okay, where F is equal to M into A, I got the answer here. Fine. So work was dependent on, indirectly dependent on force. I got the answer for force. No problem here. Now, the second word is energy. I'll go back to the previous slide. When I talk about energy, at this point of time, I realize there are 2 important ones. One is PE, which depends on position, given by the formula mgh. The second one says half mv square. Okay. Now, I can see one common thing here. Kinetic energy is dependent on velocity, but potential energy is not dependent on velocity. Now, why am I talking about this specific part? Because in the next slide, on my complete left-hand side, on your left-hand side, sorry, both of them are nothing but varieties of velocity. Getting it? So, in this case, I can't see mgh at all. So, end of the day, I should understand that this specific equation was chosen so that I do not use potential energy, I only use kinetic energy. Getting it? Now, the concept here is, if you observe properly, in kinetic energy, it says mv square by 2. So, what is there in my answer right now here is, v square is there, but m is not there, by 2 is not there. So, since I realize that, I will go back here, I will write that, multiply this equation by, let me not write into there because we get confused, I write the words itself. Multiply by m by 2. What am I trying to achieve? I am trying to achieve everything in terms of kinetic energy. Now focus. Left hand side, after multiplying becomes m V square whole thing divided by 2 minus as it is M U square whole thing divided by 2. Common sense is, since I multiplied M by 2 throughout the left hand side, I'll have to multiply the M by 2 on the right hand side as well. So what was already there? 2 was already there, A was already there, S was already there. Now obviously if I could be telling, sir, instead of writing A, we can write F by M. No, we can write, give me some time. Fine. So I'll write M by 2 here. Observe properly, on the right hand side, something can get cancelled. The 2 and the 2 got cancelled. After cancelling, what remains is only M, A and S. Okay. The S is caps. M, A, both are lowercase. Now focus. I'll come to the left hand side. Left hand side says MV square by 2 minus MU square by 2. MV square, half MV square is always kinetic energy. But here, be careful. Since I'm using two kinds of velocities, this is the final velocity, this is the initial velocity. So what I'm going to do, final velocity always gives us final kinetic energy. Initial kinetic energy, initial velocity will always gives us initial kinetic energy. Where did you learn this? In the previous recording what I sent you. Again guys, if you guys joined the class late, open the recording on your laptop or your tablet. Download both of them, name them and keep. Because after some time, it'll get cleared. The cloud will get cleared. You won't have access to the recording. 120% you will forget that because it's not difficult. Too many circular steps happening there. 1, 2, 2, 2, 2, 3, all those things. I explained in the video scene. That's why. Okay. Now coming back to the specific thing. Half mv square gives us kinetic energy, but this time it is final. What is the hint here? Final velocity gives me final kinetic energy. Minus as it is. Initial velocity gives me initial kinetic energy. So I'm gonna write Ki. Now I could have done with this. I mean, I could stop here, but I won't because left hand side cannot be simplified further. That's all. This is the maximum amount of simplification. Final kinetic energy minus initial kinetic energy is giving me MAS. This is my final thing. Now focus. On the right hand side, I just highlight MA. Fine. Left hand side is talking completely about energy done, but the question says work energy theorem. So if you see here, M into A, don't you think is nothing but force? Now do you realize as to why I was not in a hurry to write A is equal to F by M? Now by chance if you ask me, sir, by mistake if you forget and substitute A is equal to F by M, what will happen? Try it. Nothing will happen. You usually get the same answer. Instead of A, if you are writing F by M, M gets cancelled, you get F into S. Same thing you guys are getting. It's just that I was kind of calm there. I was not in a hurry. That's all. If you guys are in a hurry and if you guys are writing in terms of A is equal to F by M, completely fine. No problem at all. Now focus. In the next step, what I'm going to do is instead of me writing MA, I'll write F based on what F is equal to MA. On the left hand side already, KF was there minus KI was there. Instead of writing MA, I write F based on what? Newton's second law of motion, which says force is equal to mass times acceleration. Dot S was already there. Again, I can simplify this one more. Why should I simplify this? Go back to the question. Question says work energy theorem. In my final answer, one side should completely be energy terms. One more side should completely be work terms. Now here, this is completely energy terms. This has to be in terms of work. Think as to what formula can be used. Initially, we started with what? W is equal to F dot S. That's exactly what I've got on the right hand side, which means I'm on the correct path, which can be written as KF minus KI equals W. So in other language, wherever there's a minus, I'll let a small concept here, listen. Wherever there's a minus, we write it as delta. Delta always means some sort of change. What does the word change mean? Minus. How do we know this? How do you guys define acceleration? Change in velocity with respect to time. The word change meant acceleration here. So how do you define work energy theorem? Work is equal to change in kinetic energy. That's it. This is exactly what I wanted to prove to you guys. Fine. The symbol delta means change. W means work. K is kinetic energy. Work is change in kinetic energy. This is what this theorem called as work energy theorem states. Okay, I'll repeat it. We start with 30% of motion. Now, I have work, I have energy. Now, if you ask me, sir, why did you teach that? Don't you think this is useless? It's not useless. I'm using it here. If I didn't teach you here, it's difficult for me to teach you here. Okay, but without even writing this, I can still solve. Now, do you realize as to why I wrote this on the right hand side? This can be ignored. This can be ignored completely. Absolutely. 0 marks will be cut off from this. You will get. Okay. So we start off with V square minus U square is equal to 2AS. Please don't mug up this. Don't. I'm trying to convert the left hand side in terms of energy. I realized it was completely velocity based. I also realized kinetic energy is equal to half mv square. I try to convert everything in terms of kinetic energy. So what do? I multiply by m by 2. It becomes mv square by 2 minus mu square by 2. Since I multiplied m by 2 on the left hand side, I have no choice but also to multiply m by 2 on the right hand side. I do that. This is the result after multiplying. Thank God that the 2 and the 2 gets cancelled, which means MA and S remains. What did I write the S as capital? Because it's inside your distance. MV square by 2 is nothing but KF minus as it is. MU square by 2 is nothing but KI. This is completely solved. I cannot go further. The left hand side is completely solved, which also means in work energy part, the energy part is solved. Right hand side has to be converted in terms of work. Fine. Left hand side KF minus K is equal to MAS. M into A is nothing but force. Nothing but force. S as it is. Okay. Now KF minus K is equal to what is F into S? W. Done with this. I will keep the W as it is. I told you since there's a minus here, it means change in kinetic energy. The word change can be represented in physics using delta. I will use delta. I'll write it as W is equal to delta KE. In terms of English, this is defined as work done is change in kinetic energy. Who does this? Work energy theory. Stuff.
So why do you take kinetic energy only again? Why not potential energy?
Okay, because if you would, we start off by writing the equation, no?
Yeah.
In the equation, we have velocity. Sorry, is it a velocity based equation or MGH based equation?
What is MGH based equation?
It should have mg or h in it.
Oh, velocity.
Correct. Because velocity based equation. Yeah. Velocity is dependent on KE or PE.
Kinetic energy, KE.
That's right. Alright.
Yeah.
By chance, you choose a MGH based equation, then your answer will be in terms of potential energy. Alright.
Okay.
Guys, 100% question. I mean, this I'm talking in terms of your college also, not only board exam. 100% college question also. Don't even skip it. This is 3. Done. Go to the next slide. I'll shift. Guys, once I send the PDF, now wait, I'll give you some time to copy this, 1 minute. Once I send the PDF, don't go through all the things. I'll give you page numbers, okay? Just make sure you guys write it on the near this heading only. I'll give the page numbers. What and not to go through, what to skip. Okay? Either you write one of them. You either write the page number of what to skip or what to learn. Your wish. I'll tell you. This is from the PDF which I will send you after the class. Okay? I have two different phones. I can't send it directly as that's being used. You will learn. Okay. You will go through page number 1 of the PDF. So there are totally 34 pages. Don't go through everything. A lot of things have been useless, have been cancelled out. Okay, I will tell you what to go through. That's all. Don't even practice the illustrations. I will tell you which exact question will come in terms of numerical. Okay, only practice those type of questions. Multiple times you guys practice. I think I'll solve 4 to 5 questions. It's there on the form which I'm using right now. I'll send that also. But the numerical for this chapter, don't learn on the illustration. It is not being asked based on that. I will solve a separate thing based, for it. Okay, that's why the pattern's been changed. That's why. Page number 1 you will go through. Page number 2 you will go through. Ignore 3, 4, 5, 6. Don't learn that. 3, 4, 5, 6 ignore because it has a lot of illustrations not required. Page number 7, first half you'll learn because second half is numerical. Okay, 7, first half. It talks about definition of kinetic energy and mechanical energy. That is important. Page number 8 you will learn. This is the page number 8. You will go through 9. It's not that important, but it's okay. 9 you will go through. Page number 11 you learn. 11. From page number 12 to page number 21, ignore everything. Okay, don't learn. And in page number 21, the last part you will learn. You'll understand. Power. It starts with power from there only. Okay. Now, what is power? It says power is defined as rate of doing work. Once again, I'll come back to that. So it says power is equal to W by time. Everybody knows this. Work is given by force into displacement divided by time. The time belongs to the complete thing here. Now what? Distance by time or displacement by time gives you speed or velocity. So P will also be equal to F dot V. This is one small thing which is there, not that important because understood. Distance by time is nothing but speed or velocity. It's a displacement, no, therefore velocity. Okay, P is equal to F into V. That's the whole point. Then the next page talks about SI unit. SI unit of power is watt. Also horsepower. Learn both. Because the numerical no. So I'll tell you as to what kind of numerical will be asked. They talk about a motor pump. Again, to pump water from your sump tank to the overhead tank, the motor which we use, that motor pump will obviously use some power. That power depends on 2 things. They might either give the units in watts, but 99% of the times they will tell you that the power which can be generated from the specific motor pump is whatever horsepower, 20 horsepower, 30 horsepower. Example I'm going to give you. They'll use horsepower only. So at that point of time, you should get confused. You shouldn't be like, what is horsepower doing here? Horsepower is nothing but some sort of power. In this case, the total amount of power generated by the motor to transport water from the sump tank to the overhead tank. That's the meaning of it. 99% of the times, horsepower only will be used. But if you write horsepower as the SI unit, the answer is wrong. For power, the answer is always watt. And then the other, okay, how to define horsepower? Another unit of power is called as horsepower. Okay. They'll also ask you what is the relation between 1 horsepower and 1 watt. And watt. You should write 1 horsepower is always equal to 746 watt. This is important because in few questions you will see that once you get the answer of power, it will be in horsepower. Why? The question would have been given in horsepower. No, you're supposed to convert that in terms of watt. This will be useful at that point of time. This is what is there on page number 21 as well as 22. A mix it is. Then from 22, 23, 24, 25 are all. One second, wait. From 22 up to 25, 26 in fact. It's about collision. Don't read, watch those videos. Okay? So that part is not covered here. I am not trying to tell it's not important. Very important. Don't read from the book. Watch the video. Same thing. That's more easier in fact. Okay? So 28, 29, you will ignore. 31, 32, 30. Okay, 31 through 34 is the exercise. Just go through it if you want to. Okay. So, okay, total page is 34, but up to 31 is where the content is. From 31 through 34 is the questions. So, up to 31 minutes, I've told you what I'm going to do. Okay. Again, I realize that I've asked you to cut off most of it because that's not important. I'll take this time to tell you what kind of question will be asked in your numerical by itself has been asked. The question goes like this. A pump on the ground floor of a building can pump up water to fill a tank of volume 30 meter cube in 15 minutes. 15. Full stop. If the tank is 40 meters above the ground, if the tank is 40 meters above the ground, the efficiency of the pump is 30%. How much electric power is consumed? This is the kind of question. You should not write it. I'm just going to tell you. So they'll usually talk about the pump only. 99% of the times they won't even change the appliance. They'll keep it to be pump itself. They'll start pumping water from the ground floor to the top floor. I mean to the overhead tank. That's exactly how it works. They will give us the data about all these things. They'll also tell us what the efficiency is. Efficiency is always represented by it's called eta. Just tell N. Okay. So let's say it is 30% efficient. This will be given. There's a very easy shortcut to solve this question. It's a 5 marker. Okay. But at this point of time, let's not talk about that. Apart from this, no other numerical will be asked. If there's any numerical based question, it might be asked as a 2 marker numerical, which will be based on either this formula or this formula or this formula or this formula or this formula. All of these you will already know. You need not learn about anything. So 2 marker numerical is more like an instinct numerical. You will already know the answer. Where you might go wrong is writing the units. That's why I took some time to revise. Okay. Now coming back to work energy theorem, finish this off. This means delta represents change. So today's class, we are done with the theory part of work per energy. Once you guys go through the PDF, change. Now tomorrow's class, we'll do organic chemistry. Fine. The second chapter is called as hydrocarbons. You guys miss it, it's completely your loss. I'm telling you right now. Okay. 120%, the chapter is very important, not only for this year, but for your next year also. And you guys take the choice.
What are you doing tomorrow?
Organic chemistry, second part, hydrocarbons.
Okay, sir.
Okay. Guys, understand, there are a lot of mechanisms. I think I will take 2 to 3 days to finish off the complete chapter. Okay. You missed the first day, ignore second day and the third day. I'm only telling you. There's no use because first day I have gone so deep about it. And the second or the third day, more than me trying to teach you, you will know what the answer is. And each and everything, the answer might be 1 page long. All are mechanisms. So first day only, I'll teach you how to write step 1, step 2, step 3, step 4, how to conclude. Second day, if I tell step 1, you will be in a state of writing it on your own. If I tell step 2, you will be able to construct the whole concept. Fine. You miss tomorrow, it's completely up to you. Again, in tomorrow's class, not everything is very difficult. Starting, I'll be doing little dense kind of stuff. What else? Meaning of alkanes, alkenes, alkynes, double bond, triple bond, single bond, what breaks, what does not break, how is the breaking happening. This also will be included. But Moreover, most importantly, I will be talking about how to write mechanisms. Because from that chapter, 100% one 5 marker will come, and that 5 marker will be a mechanism. Totally, there are 4 to 5 mechanisms, out of which one will for sure come. Okay. Now decide to attend on. Okay, that's completely your choice. Finish off first. I'm supposed to write a statement also. Statement in this case is very important. Don't mug it up. Comment upon this. What does the left hand side mean? Left hand side means work. Work done is equal to delta means change.
Excuse me, sir. Sir, our ma'am is telling we can't write KEME and all.
What is KEME? Oh, right, kinetic energy.
Kinetic energy. She's asking to write the full word. Or she'll
Right,
cut marks, it seems.
I don't know, something is wrong with the ma'am, I guess. To be honest.
She's like, for these derivations.
Is she fine if you write F and S?
Yes.
No, why are you laughing?
No,
Huh?
FNS is okay. She's
Why?
telling for kinetic and potential energy and mechanical energy.
Okay, now my question is, she's telling, right, instead of writing KF, write final kinetic energy minus initial kinetic energy, correct? No.
Yes, sir.
Right side W is fine.
Yes, sir.
Sir,
What will I tell for this? She's fine with W because W means work, and she's not fine with KE and PE or whatever.
Sir, maybe she was doing this derivation. 10th standard we had, right? At position A, position B.
That's not important, don't study.
That derivation she told you have to write full letters, full spellings. For that we cut 1 mark, it seems.
Stick on to the same thing, whatever rules she's telling, because it varies from college to college. No, I'm talking with respect to board exam. Board exam they'll give you, because everything has a meaning, and there's a reason as to why they use shortcuts to save time. And what is this? They're telling don't write F, write force means doesn't make any sense to me. Okay.
Okay, sir.
Do one thing. This chapter is almost done with respect to theory. Nothing else is left.
Sir, she did 2 more derivations. Work, some derivations she did.
Work done by variable force.
Yes, sir. Variable force
One
and
from. Don't worry, one from. Don't read that also. It's waste of time. Wait 1 second. Guys, write one important thing I'll tell you. Difference between conservative force and non-conservative force. This I'll explore. This is important. Okay, listen. Example. Listen. These two things are kind of irony, okay? Tell you what I mean. Non-conservative means it depends on what I tell you. It depends. Conservative means does not depend. How to remember? Wherever the word non is there, opposite one will not depend. Okay? Here there is no word. Therefore, this one will depend on what? On the path. On the path. So it does not depend on path. What does not depend? In this case, work does not depend on the path. In this case, work depends on the path. What's the example? Gravitational force. I realize that you don't understand anything. What is path? I'll tell you. Okay. Here it is viscous force as well as friction. Viscous is viscosity. You take that ball and drop it into castor oil, that concept. Okay. This is what I'm trying to tell you. What does this path mean? I'll give you one example in two different variations. Point A. Agenda is very simple to reach point B. Where are we starting from? We're starting from point A. Now, let's say agenda is what? From A to B. There is nothing else given to us. From A to B, just keep going. Now, if I tell you, let's say you guys are actually traveling. You have an option to fly from A to B, or to take the road, or to walk, or to cycle, or to swim, or to do n number of things. Okay. The only thing is, what my question is, come faster. Let's say that's the whole point. So what you do, depending on your resources available. See, you might think flying is the best option, but do you have the resources? Will you be able to access the airport? Will you be able to access a chopper? Depends on whatever resources you guys have. Now, let's say here a person flew. He flies from A to B within n number of hours. But let's say a person is coming by road. Okay. He takes a stop here, a stop here, a stop here, a stop here, a stop here. Let's talk about two people, person 1 and person 2. Person 1 who flew. Person 2 by road. If you ask both of their stories, both of them will have the same destination, but end of the day, both of them will have two different stories. Both same thing, two different stories. Now, if you talk about person 1, he'll be like, I boarded the flight at A, I came to B, I took so much time, story done. Okay, nothing wrong in the story. Work, still got, he reached the destination. But if you talk to person 2, he will give you a story minimum for 2 hours. Full content he'll give you. He'll be like, from A, I went to point C, I met one person. With that person, I traveled to point D. At point D, we went to a restaurant. That restaurant, this happened. That we fought with that person. A, here, E, F. He'll tell so many stories, and then he'll be like, after doing so much of work, I reached point B. Have you seen all these boomer uncles? They tell, like, hey, by the time I achieved whatever I achieved in life right now, because it took so much of hard work, A, B, C, D, E, so much of sacrifice, n number of things. Now I achieved that. Okay. There's another person who tells, this is what I was lucky enough to become this. Both are same thing only, successful. But the way they tell the story, here full obstacles they tell, which means they feel that it depends on their path. They are wrong or right, I don't know. That is completely your judgment. But end of the day, both of them reached the destination. But stories were different. Path 2, or I said the person 2, it depended. For him, it depended. What happened at point C? What happened at point D? What happened at point E, F, G? Everything had to play an important role for him to reach B. But for person 1, only what was happening at A was good enough. A, he boarded the flight, came to B, job done. Okay, both of them are correct, guys. Don't let me down. Both of them are correct. This person's story has more amount of obstacles, has more amount of smaller stories, smaller incidents, many memories here. Here, coming back to this, non-conservative force tells it is dependent in nature, depends on the path. It is like person 2. What are the example? Friction. Think about friction. You just can't keep floating in air and tell, oh, I'm experiencing friction. The moment your leg touches the specific ground and you're trying to walk, some force is trying to stop you. What's that force? It is working against the ground. That force is called as friction. Simple. Viscosity also, the moment you drop the ball into castor oil, you guys do it in the their labs. The castor oil won't make the journey very easy. It'll try to resist. Even though it is trying to resist, what can happen maximum? The castor oil will move from the top to the bottom little slowly, but it is still moving. Okay, it is still moving. And if you ask that metal ball the story, it will be like at point A, so much opposition I suffered. Then I kept on moving, which means it was depending on the path. Gravitation force, you throw whatever on top, it comes to the bottom. You throw whatever. Okay, there is resistance. It's just that depends on the mass of the object. For example, the pen, I drop it, it is coming down due to gravity. But the logic is how it works. Reason is because the pen is more stronger compared to the gravitational force. Not everything is, but still with the pen. So here it does not depend on the path. I drop the thing from the top into the down. But talk about this. If I take I take the same metal ball in both the cases. Take the metal ball, drop it in air. It falls within like 1 second. Example. Pick up the same metal ball. Take a tube of castor oil. Drop that metal ball in the castor oil. By the time it reaches from top to the bottom, it's gonna take more than 6 to 7 seconds. Why? That liquid is trying to oppose the metal ball. Whatever happens, it won't make the journey smoother. So that path is called as non-conservative path. This path is called as conservative. That's very important. Copy this. It's there in the PDF also, but explanation is important. Examples are very important, guys. Left hand side is gravitational force, right hand side viscous force, friction. There are 2 or 3 more points which is there in the the PDF which I'll send you. Done now. So tomorrow. Chemistry tomorrow, organic chemistry. See you. But once the class is done, go back to WhatsApp, download both the recorded videos and keep it. Name them and keep it. You won't realize at this point of time during exam you'll forget those smaller steps there. Getting it? Yeah. See you.